So let's start. Hello, everybody. Welcome to this last session of today here in this auditorium. I hope you have enjoyed with the horchata and fartons, typical from Valencia. Don't be afraid, because this is the last, but probably the most interesting session today about the railway domain and the use of the IFC 4.3 and the adoption of this standard in the whole industry, and with several different perspectives from clients, infrastructure owners, the industry, engineering firms, and software developers. So we are going to have different points of views complementing the whole topic. So we are going to start with our first speaker. He's Eivind Pagander Tysnes, co-chair of the railway domain in buildingSMART International, BIM manager in Banenor. So thank you, Eivind, for being here with us. The floor is yours. You have 20 minutes.
Thank you, Jorge. Thank you for having me. And coming from the cold Nordic, coming down to 15 degrees has been lovely this last couple of days. I'm going to not talk about my job. I'm talking about what we're doing the railway domain, what has been done, and what we're going to do forward, what lies ahead of us. So what was? Somewhere between 10 and 7 years ago, the railway domain started. They've done a lot of work. Most of the work has been with the IFC rail project, which ended now up in the IFC 4.3 as part of the IFC 4.3 standard. The development has taken a long time, 3 phases. I'll come back to the phases a little bit later, but 3 phases, one of the biggest projects in buildingSMART, and we have got a standard that we can use, but we also need to implement it. So phase 1, you see if I have more on that. No, phase 1 was starting with a taxonomy, getting all the objects in, all the entities in, all the properties in, defining everything. I wasn't part of that. I came in at the back end of that and started more or less with the phase 2. So I wasn't that much involved with that. But there's a huge report that says everything about the objects and the properties that was needed for the different parts of the railway domain. For railway is very complex, so doesn't have one discipline. We have a lot of disciplines. So we have signaling, we have energy, we have telecommunication, we have electric. So we have the OCS systems, we have the track systems. So and also we have all the common facilities with. That's also common for roads, the geotechnics, the subsurface, and all of that as well as bridges and alignment. So we have a lot in common with them as well. For phase 2, we were starting testing. We had to test and see that the standard and what we have done would be able to work in the standard. That took a long time. It was finished, if I remember correctly, sometime in 2022, I think spring of 2022. And phase 2 that was going into what is now the ISO standard, updated ISO standard of IFC. And that was a huge task, and I can only thank everybody involved with it, the stakeholders, the project management office, the technical team inside of that. And then last fall, we finished phase 3. Phase 3 was looking about testing an application of implementing the IFC 4.3 and applying IFC for rail so that we can actually use it. And that's where we ended. So that what was. And present, what are we doing today? We have a steering committee, but the railway domain isn't a steering committee. The steering committee is just there to govern and help lead the railway domain in the right direction. The railway domain is everybody interested in railway, in building smart and everywhere. So please reach out to us. Earlier today, we presented a rail manifesto where I think 9 stakeholders and members of Building Smart have said they want to do this. This is about, the manifesto is about using and applying the openBIM standards in their organization, education, training, and using it and trying to do it similar, try to do it much more similar as possible. What lies ahead of us? What's in the future? I'm just coming from a 90-minute workshop where we're looking at new roadmap. Just from that 90-minute session, we got 17 topics, including further development of the IFC rail schema, of education and training, of user guides. What else can I mention? BIM and GIS. There's a lot to do, and we can't do that without the rail community around the globe, including you here in Spain. It's not possible for us to do it without you, because we need feedback from you. We need to know what we should prioritize inside railway domain. And it's not me as the co-chair or the steering committee alone who decides this. We need the feedback, we need to do everything. So we started the process of making a new roadmap now, today, and we'll probably use maybe upwards to a year. If Spain wants a roadmap workshop here in Spain, reach out to us, and we can probably have a workshop to get feedback from Spain, what's important for you here in Spain. New activities. Tomorrow at 11 o'clock, if my mind doesn't cheat me, we will have a workshop with stations and airports, where we'll start looking at what we need to do to be able to have all the entities, or what we need to do to define a station and an airport. A lot is common for stations and airport. Ariska mentioned that yesterday in her presentation about what's common and long at an airport. Vending machine, ticketing machines, security gates, chairs, resting areas. A lot's common. So we're not alone, we can do a lot together. Like BIM GIS, it's not a railway domain specific one, it's cross domain. The infra domain is very interesting as well. We have sustainability, there's a lot we can do, but we need everybody to help together, everybody going in the same direction. So I mentioned the station project, and we will want, probably that's a huge benefit, not for railway, but also for others, because we can have something that's ready to use when we're done, hopefully. Industry forums. This is something relatively new. I think only the infra domain and the construction domain has done it, or product domain, but we want to engage more with the community. So I expect maybe as early as that after summer, we will do webinars where we do invite the whole all members of Building Smart International Building Smart chapters to come join us for where we talk about what we're doing. We get feedback from you guys to see what can we do better. And my guess is the first couple of industry forum will be about the roadmap. That will be my guess, or maybe like the station project or something like that. And yeah, community. You're the community. The railway domain consists of all of us, not just the steering committee. I think that's very important for you to understand. If you want to say something, come to us and contact us. Don't be afraid. We much rather have you come to us with the information you need, the information you want, and be part of the community. Richard Petrie and Patrick McClamey has always said IFC is the International Friendship Club. Friendship Club has to be a community. We can't sit on different sides and not talk to each other. We need to talk together. That was a short presentation from me. My contact information is there. You can also contact the railway domain at railway@buildingsmart.org. And thank you for having me again. Gracias.
Thank you, Eivind. Thank you for this inspiring speech and message for all of you. Please don't forget his request for feedback. I think feedback for him is the energy source of their work. So it's very neat to have the feedback of all of you, of all the users. So thank you, Eivind.
Thank you.
Thank you very much. So we are going to continue with the next speaker. Next speaker is going to show us the point of view of the owner of the infrastructure. He's Francisco Luna. He's manager of railway operations support systems in ADIF. So, Francisco, the floor is yours. Thank you.
Okay, thank you, Jorge. I belong to the IT department in ADIF, the Spanish railway infrastructure manager. I'm going to talk about the steps that we have done toward the digital twin in our organization. Okay. First of all, let me say a few words about our strategy. Yesterday, Javier Lozano, also from ADIF, treated it deeply, the strategy in ADIF towards BIM. This presentation is more technical, okay? But let me say a few words, okay? About ADIF. It's a public company attached to the Spanish Ministry of Transport. We are responsible for design, construction, supervision, and maintenance of rail network, as well as network traffic management and station, okay? And we have done a big investment in conventional high-speed railway, okay? So about our strategic plan, it's based on 4 pillars, 3 levers, and 10 challenges, okay? Some of these concepts are very related to the open data strategic that from the IT department are involved, okay? And open data means to adapt to open formats. Open format like OGC services, like RailML, or also, why not, IFC, okay? And these are our global figures. We have nearly 60,000 kilometer rail network and 1,500 passenger stations, okay? Now I'm going to talk about the steps from this to BIM. Why I focus on this? Because if you take the definition of digital twin as a digital representation of a physical asset, integrating geometry, attribute, and relational information among elements, let's imagine the big amount of geometry that we will need to cover all this station and the whole network in a high level of detail. So we have to be clever in the strategy. So from a basic level of detail, less ambitious, where a station can be a point and express the connectivity between this station with the center line, to approach toward BIM, okay? So let me explain what are we doing in the IT department in a project named the Spatial Data Infrastructure, but we update every 3 months in our company. We have to do these 3 basic steps, and it's very important for every other company. I don't know if in the room are other people from the railway administrators. I know some of them, but I don't know how many. But I think that they understand what I am going to say, because you have first to stay with the topology concept of the railway, okay? You have to understand how many nodes do you have and the connectivity between these nodes in our end-to-end relationship. You have to connect to the traffic management systems and update this topology concept every time that changes the situation of the railway, okay? When you have established the topology, you have to cover then, in a second step, the geometry and link the geometry to the topology. In this basic level, our geometry is a geometric point, as in the station, and a center line, the connection between these points, also in the same relationship that the topology. Okay, I have to say here that in ADIF we have been working during many years in a common segmentation. This concept is very important to understand our segment of the railway in the same way for all the departments of the organization. Let me give you an example. For example, if the traffic management department say, okay, I have to split this segment into 2 little segments due to technical reasons, and want to cover it in this common segmentation. Okay, but then the accounting department can say, no, please, I have many assets and I have to reassign to this little segment. Why are you changing that? So it's important that the departments in this kind of organization talk each other to establish this segmentation. But if you get this goal, then you have the ability to upload attributes for your system, because you can cover this geodatabase with all the information, understanding that every department talks in the same way to interpret the railway. The railway is the same for all of them, but the way that they understand the segmentation can be different. So it's very important that every department understands the same way, okay? So this is the second block, the geometry, and there is a third block, the location, very important to understand how to make any location of any event, any incident that happens in the infrastructure for all the departments. Okay, if you have some problems in a point kilometer and a line, you have to make this translation to a geometric coordinate, longitude and latitude, and in what direction. This is very important. You can do this with dynamic segmentation processes in our GIS system. And of course, these services can be consumed by any internal system. Okay, so if we cover these 3 blocks, then we can publish this information of this geodatabase adapted to open data format. For example, OGC services, also the Hermes project from our Ministry of Transport, and also in Street Cloud, you can find this service. You can go to this website and look for it, okay? We also adapt to another formats like RailML, SafeFile, or KML, okay? So, well, this is a clear situation about basic level in a GIS system of a railway network, okay? But let's jump to an expert level, okay? Now the topology is not so simple. What we have done, we have followed UIC recommendation, and they talk about the micro, the meso, and the macro level, okay? 3 level, important to aggregate and disaggregate the information of the network. Also, you take care of the connectivity, and you take care, it's more complicated, to connect to the traffic management system to establish the topology in the organization. Once you have established this topology, you go to the geometry again, And of course, you have to establish this common criteria again, but it's more difficult because you have some other discussion with the departments. For example, in our organization, it's very important, make a question. When does a station begin and ends? If you ask to the traffic management department, you can have a different answer from a maintenance department or a logistic department of the station department. So it's very important to understand the same criteria for all the departments, okay? In our case, we are focused on the signaling, on the entrance signaling in the station, but other railway administrator can cover it by another criteria. But this is very important to establish this geometry. The macro level in our case is an area geometry, okay? There is a meso level, an intermediate level of geometry, also very important, that indicates, for example, that a junction, a group of switches, is not a station, but you have to cover it with a geometry, okay? And then we go down to a micro level with the switches as a point and the connection between that and the center lines, okay? We establish the common criteria and the attributes of the different application in the organization can cover all the characterization of the network, okay? And finally, let's go to the third block, and we are getting closer to BIM, okay? Where we can find some processes, interesting process, extrusion process to cover all the information of the building that have in the organization. Maybe we have not received the BIM modeling, but we can combine the BIM modeling with other building extrusion, okay? Also the elevation coordinate. And of course, it can be published as a service and consumed internally in the organization. And we want to do the same, publish this information outside, adapted to many formats, okay? I have to say that this is under construction, but we hope that in 2 years, we can publish this information in a more level of detail, okay? So let me talk a little about the BIM GIS integration, okay? Then we are focused on 2 directions, from BIM to GIS and from GIS to BIM, okay? The first one, from BIM to GIS, is important because we have received a lot of IFC files, and we have S3 platform as our GIS provider, and S3 are doing big effort to adapt IFC to do the mapping of their entities into their way to understand a building layer and a 3D scene, okay? So this is important for us that S3 can cover our requirements. Also, it's important to know that we have a lot of these services from years ago, and combining the information of the 3D modeling with the GIS services can do a very, very intense analysis of what is happening surrounding the building, because we have services with telecommunication, management services, of traffic management services, and land expropriations, okay? If you combine these services with the BIM model, you can discover a lot of conclusion, very interesting, okay? And also in the other direction is very important. We have developed a lot of geographic viewer, and okay, we connect to our common data environment. I'm going to talk about it, and to cover all the entities that it has, issues, files, documentation, photographs, or the projects that we have, combining and making the transition from BIM, from GIS, sorry, to BIM, okay? So let me talk about the implementation of BIM in our organization, okay? First of all, I have to talk about the strategy. And we had in this long journey a fellow traveler, a very important and strong fellow traveler, that is ICOM, a big company with a big experience in implementing BIM. So, they helped us defining this strategy based on blocks like BIM system, the tendering, the training is very important to generate a cultural change in BIM in your organization, and also the IT where I belong. And of course, we have to analyze all the processes, the internal processes that have in the organization, and identify the traditional processes and those ones that can turn into a BIM. Okay, that's important too. Also, we have another fellow traveler very important as Ineco, a Spanish company that has the leadership of defining and coordinating, and Jorge knows very well all these standard, the openBIM, and of course they helped us to define and implement the right solution. We selected Autodesk Construction Cloud, and we have all these projects. All these companies are working for us. This is the information about the active users we had. We make together with SAIS, also an important company in Spain that helps us to define the parameterization of the common data environment to cover the ISO 19650. And we also uploaded a lot of files, a lot of information from non-BIM files that we have about technical documentation since a long years ago. We had a lot of CAD files, PDF files, but we wanted to migrate also to a cloud environment. I think this was a clever strategy, because we have a whole vision of the company. So many files are not BIM, but we can combine with BIM files, okay? This is the data that we had, okay? A lot of IFC files that we have received, okay? Let me talk a bit about the common data environment in ADIF, okay? We have our own common data environment, but we know that our provider has also their own common data environment. So it's very important to make the right communication between the CDs, okay? So when they send us IFC file, it's important that we establish IFC guidelines and establish the attributes so they can fulfill the property sets and set in a right way the IFC, okay? We are working on an IFC validator, okay, integrated with our system. We are using a very interesting tool here, is FME from Safe Software. It's an ETL tool that can understand the geometry and the attribute, that can aggregate and deaggregate and establish the connection with our system. And we also, of course, use the Autodesk platform services, known also by the name of Forge. And of course, also IFC, but we want to upload BCF and connect with the issues that understand this platform. It's very important that Autodesk can import and export the BCF file, okay? This is not the final solution. We are reviewing the situation. We want a global openBIM solution and not establishing a PDF file with our guidelines. We want to be more integrated with IDS, BSDT, and we are reviewing internally how can we get this final solution, okay? So finally, I want to say a conclusion. As you can see in ADIF, we are a public company. We demand openBIM. We cannot say to our provider proprietary files because we are public. So it's mandatory for them to prepare this information in IFC. But as you can see, we have selected proprietary platforms, okay? So, well, my message is for Autodesk and Esri in that the continuity of this platform that we have in ADIF depends on their ability to adapt to openBIM, okay? So thank you very much.
Thank you, Francisco, for this impressive, in my opinion, panoramic view. A lot of work done, a lot of challenge for the present and the future, and the application of the standards that we have just seen before in a real organization, in an organization that is in charge of the whole life cycle of the railway infrastructure. And we are moving from the general to the particular. And now I'm inviting Lucia Capilla to the stage in order to talk us about a particular project in the station of Madrid Chamartin. Lucia, the floor is yours. Thank you very much.
Thanks, Jorge. Okay, hello everyone. My name is Lucia Capilla. I'm a BIM manager in TIPSA, and now I'm working as a BIM coordinator for an emblematic project in Madrid, Chamartin-Clara Campoamor Station, which I'm going to talking about. I'd like to introduce some information about TIPSA. We are a Spanish multidisciplinary engineering consultant with international presence in 25 countries and more than 20 companies in the group. In 2009, we worked for the first time using BIM modeling software, and in 2014, some disciplines worked together, sharing and coordinating their models. It was in 2018 when the BIM department was born. And we were the first Spanish engineering consultant to get the BIM certification. The present and the future of the company is our digital strategy. Well, in these 20 minutes, I would like to give you some context of the project, technical coordination assistance in Madrid Chamartin-Clara Campoamor Station. Chamartin Station, okay? Challenges that we have found and how the openBIM is essential to resolve them. Well, Chamartin Station is located in the north of Madrid, close to the Five Towers business area. The station was originally built in 1967, and the city has continued to grow. Currently, the station and its rails are a barrier for the connection in this area. Exists an urban development plan to build a new modern business area around the Chamartin station. This development includes green areas, commercial spaces, residences, and of course, Chamartin needs to be a part of the transformation. Finally, Chamartin wants to be an intermodal station that provides the right service to all citizens. From this point of view, you can see the huge area is involved, 197 hectares, more or less. Due to the extension, this project is divided into 4 large sectors to organize all the information more easily. Although I'm repeating myself, I want to emphasize the size of the project so that you can understand the challenge of coordinating among many actions. Because I think it's the most important feature of this project. Our main objective is the coordination and information management of every action within the general railway system. ADIF and TIPSA were aware that the best way to face all of this was through BIM methodology. With TIPSA experience, in addition, the creation of a federated 3D model will be the best tool for managing and coordinating more than 70 works that share the same location and construction timelines. After this explanation, I hope you understand the context of the project, and I'll continue with the challenges that we have found. I want to remark again the complexity of this project, which involves more than 70 projects. And right now, after working for 2 years, we have 22 projects. Joined in a unique global model is 507 megabytes with 177 submodels. You can imagine the magnitude of the final global model. Because of that, we have to code them with numbers and letters to organize. I have tried to give you a principal challenges that we have found. There are many projects in every phase at the same time: feasibility, schematic design, detailed design, as-built. It means 3D models have different level of details because each phase has different ADIF requirements. In the second place, the projects are of different nature: building, urban, railway, energy. It means different native software to adapt and resolve the needs of each one. Related with the softwares, in third place, and I said previously many times, there are many agents, and each company is free to choose any software available on the market: Autodesk, Bentley, Istra. And finally, we must keep the station operational and guarantee safety and connection with the city and the rest of the country. And in the list of challenges, I'm sure we all find confidentiality conditions in every project. But in this case, ADIF has found a singular situation because it's necessary to share an information model among many agents. The ADIF legal department has been working very hard in a confidential agreement that everybody has to sign. For that, I'm sorry, but I can't show you more pictures from the global model. Well, for coordinating, the answer is openBIM. Everybody must speak the same language. And from the beginning, ADIF has established common standard for everyone who starts a project. TIPSA, 2 years ago, received the manuals, guides, everything about BIM methodology that ADIF wants to implement. TIPSA analyzes it and determines some minimums for this technical coordination assistant in Chamartin Station. And we have the mission to watch over it. These minimums are georeferencing, exchange format, max size, parameters, and model breakdown strategy. I have to say that ADIF generally asks IFC4 like exchange format, but 2 years ago exactly, on March 22nd, when we received first model from different agents, we made some tests, and some software didn't work with this format how we need. So we decided to establish IFC 2x3 as an exchange format because it worked. Okay, and it's absolutely necessary to have a common data environment where we can work together and respect the confidentiality that I talked about earlier. ADIF provides its platform for all its projects with strict requirements, but in this project, we need a space, a special space, as a meeting and collaboration point to share information and establish communication between agents. In addition, we can manage permission and security levels. And the primary tool for coordinating and supporting ADIF over time is a live federated model. This federated model changes during the construction phase because we start from schematic or detailed design models to as-built. At the same time, we receive models from different agents in IFC format and their minimum standards, and we need to analyze them to check and verify them. Okay, so agents develop their models and share them in IFC. We fuse these models into a unique coordination model. We analyze the collisions and we share them in BCF format to all parties. Again, the open format is key to communicate and coordinate the collisions. These class detection reports are essential to anticipate issues, and each part can adapt their models to resolve them and get a viable design project at the end. Well, TIPSA has developed a virtual room as a unique digital environment where ADIF can find documents or files useful for the coordination, with a dashboard to organize and display the most important conflicts detected by us, and to find them quickly, and they can see their evolution. Okay. And well, conclusions. So this project is a great example for openBIM. In all projects, an universal language is essential to get the best coordination, and for sure, in a huge project like this. I want to share, again, only a warning that we have found. As I told you in March 2022, not all software was at the same stage of IFC development. For that reason, it's important to know that development on open format is an advantage when start and plan a new project, and you or we need to choose a software package. And well, therefore, collaboration, interoperability, and global use, in our experience, are the answer for the quality and control management in this project and every project. So thanks for your attention, and it's done.
So thank you, Lucia. Very interesting project. We have started with the organization that requires, that was ADIF, and Francisco explained us all the systems, the whole panorama from his point of view, and now the application of this vision in a real project, in this huge project in the north part of Madrid. And we are going to follow the session with another part, the one that makes it possible, software vendors. Some of them were talking about software all the time, and now we have with us Alberto Pastor come to the stage. He's the product owner of the Istram software that is implementing IFC 4.3. So thank you, Alberto, and the floor is yours.
Thank you so much, Jorge. Next. Okay. In this presentation, we are going to see how the IFC 4.3 has been implemented in railways design software. Who we are? I'm Alberto Pastor, and I work at the Buodra Ingeniería company as a product owner in several BIM implementation projects. Buodra Engineering is a software development company. Buodra develops tools for civil engineering, and is the company that created the Istram application. Istran software is a platform with multiple modules that are integrated into the same interface. The software was born in 1989 as a small CAD application to resolve terrain models, and today the project is working in BIM methodology. Istran is a software for linear design projects, for planning to controlling elements in construction phases. The types of the projects are very varied: roads, highways, urban networks, railways and trams, canals, water or drainage networks. Other projects are mining and solar and wind parks, and has a module for monitoring earthworks. Here's a brief presentation of what the software does. All linear infrastructure projects are based on terrain models, laser scanner data, and other formats of terrain information. The objects are associated with alignments. Some objects are created by cross-sections, and finally created surface objects and solid objects. Istran includes drainage structures, tunnels, and bridges. Finally, animations can be generated for all objects for presentations or of time analysis construction phases. Well, what type of specific information do we need in railway projects? One of the most important data is to have a global coordinate system of the projects registered. It's important for good model coordination. Some models have local coordinates like a train station, some bridges. Other objects have a linear positioning, such as signs that are distributed over kilometer points. Other objects are in local coordinates, 0, 0, like elements in libraries. We need the geometry of the alignments. The alignments are the geometric guides for the construction of the model. They are used in both components, the horizontal and the vertical design. This design has a complex curves that must be recorded, such as clotoids, parabolas. A project can have many alignments which have to be organized. The sum of both types of alignments generates a fundamental 3D guide to place the objects. Another important concept are the cross sections. There are the primitive elements that generate extrusions through these cross sections obtain the 3D corridors that are part of the BIM models of a linear infrastructure. It could be interesting to have these entities in the openBIM files. It would be to use for the construction phases. The cross-sections are very useful for checking the BIM model with correct measurement on the appropriate measure plane for the stakeout points. As you can see on the screen, the position of the pointer is projected of the model, offering the closest control sections on the screen. Beyond conceptual entities, object classes specific to railway project are needed. At the base of all these projects are the elements that shape the terrain to reach the level surface of design. There are many, but of the most important are earthworks, both for excavation and filling. Within these types, there are different uses, such as excavation and different levels of geotechnics. And finally, in this review, the elements most related to the railway, elements of the superstructure. some examples are railway tracks, such as rail, sleeper, or slab track. All disciplines that focus on facilities such as railing, signaling, catenary poles, catenary electrical conduits, switch, and turnouts. Now, we will see how all these railway concepts have been implemented in IFC within the Istran software. For a few years now, infrastructure BIM models in Istran can be generated based on the IFC schema of versions 2.3 and 4.0. This is a common structure in Istran projects. In IFC 2.3 or 4.0, there are generic classes in which the railway elements can be housed and a special structure can be organized the data. An example spatial structure in some railway projects carried out is shown on the screen. IVC project, IVC site, IVC building, building story, as groupings of some elements. But there is no spatial structure for railways, no special entities for railways, and there aren't classes that define the alignments. Fortunately, today we already have available in openBIM a schema extend to the wall of railways. Thanks to years of work that buildingSMART had dedicated to expansion of IVC schema 4, today we have the official version of IVC 4.3 schema. Now, with schema 4.3, there are specific special structure to organize railway projects. This is an example of a railway project. EFC facility is used as a group of corridors. Within these groups, there are railway corridors in IFC IFC railway part, there are longitudinal divisions. In each sections for this segment, there are different groups such as excavations, superstructures, signs, and other set of elements by use. This is an example of a project of railway. In IFC 4.3, there are specific classes to store the alignments. Each alignment, whether horizontal or vertical, is made up of sequences of smaller entities, such as IFC alignment segment that record the data for each segment, such as clotoid values, points of tangent, lengths, etc. In Istran, all alignments entities are linked to the IFC entities. Here you can see the writing of the IVC file in step format. The main alignment of this project is double via Madrid Ávila, which includes in horizontal alignment. Each IFC alignment segment is a part of IFC horizontal alignment. It has attributes of clotoids, straights, and circular curves. The second part, write the vertical alignment. All the IFC alignment segment is a sequence that degenerate the vertical design. On railways, there is the possibility of registering the railway count. IC 4.3 has a specific linear railways entities. In this case, the railway entities for airworks are shared with the rest of the infrastructure projects. Now I'll see the elements have their own class and their specific standard properties. In this case, these solid objects has entities can be choose predefined types. In this example, the corridor object need to write in solid geometry. For this project, different geometries were used for different objects. For those that had volume measure, the solid were generating users the IFC entity for geometry. With the IFC facility BREP has a sample of fields, excavation, or ballast layers. These solids can be checked with volume formulas that take into account all faces of formed triangles. And this project had a requirement that the measures are also checked by cross-sections. Each cross-section has an area that produces a volume. Some formulas calculate this volume, but the results are different than the result of geometric volume. It's similar, but different. How can we write both methods in IFC models? First, we have already seen the solid by IFC facility BREP. The second, I suppose, are several ways to store the cross sections and related to the alignments. In this case, we use the IFC open cross profile depth and another like it as closed profile. We create a sequence to record on each surface created in the model, a profile that defines the cut at each kilometer point. Each profile has a connection point on a 3D polyline formed by the alignments. Each point in the profile allows to associate a label of tags. Well, now specific railway entities are in IFC for the 3. There are many entities, many entities. Here I show some of the most basic ones, such as rail, sleepers, some digital element of railway communications. Many of them have predefined types that give a possibility of researching a very deep level of organization. In IFC 4.3 not only has entities. Many of them can be related to P-sets created for railway projects, as well as a specific quantity set for new elements. This standardization is important for communication between softwares. Because user P-sets, we always need some types of conversions maps. The standard P-set is the same. All the standardized P-sets, predefined types are in English language. For many Spanish users, it's difficult to choose between predefined types in the English language. We applaud a great project that is underway to translate IFC 4.3 into Spanish language. This project led by buildingSMART International and the buildingSMART Spanish Charter are working to translate these terms for the entire Spanish-speaking community, and which is published in the buildingSMART Data Dictionary service for all users. Finally, ISTRAN includes the latest railway classification systems that have been published in Spain. These classification systems are registered in the IFC schema entities prepared for this, such as IFC classification, right, and IFC classification reference. It can also be used, as always, in properties within the user P-sets. To facilitate the expansion in the use of open models that use the IFC 4.3 schema, ISTRAN have released the first version of a free model viewer. If the model has alignment, you can access alignment information, both horizontally and vertically, view the railway spatial structure, used an visual representation of 3D objects, entities, and their properties. And now a cross-section if the module use IC Open Profile Def. Other standard formats such as length XML and LAS or laser scanning data. Finally, why did we implement IFC 4.3? Because the open communication between design software is important to coordinating. Railway discipline requires specific data that IFC 4.3 already has. But it's also important for railway administration. Now you can have data open to check regulations for your own monitoring without need for a specific software to extract the information. And also for construct companies in infrastructure, it is common for a stakeout of topography points on site to be carried out based on alignments. All these processes are more transparent, more automated, thanks to arrival of IFC 4.3. Thank you so much for attention.
Thank you, Alberto, for this presentation. So with this presentation, we've finished this trip from the general point of view to the practice, going through the requirements of a railway agency like ADIF, the implementing in a huge project like the Chamartin Station, and the way to make it possible, the software, and the implementation in a very practical way of this schema that we are able to already use. The schema was approved very recently, I think in January, and there are some tools that allow us to use it nowadays. And there is, in my opinion, a common outcome from all the presentation that is that we, in general, we need open formats. We need open BIM to address all the challenge that different organizations have. And we have the chance, we are very lucky because we have the chance to use it already. So thank you all the speakers for this inspiring session. Thank you all of you for being here attending this session. Enjoy the end of the day, probably visiting Valencia, and see you tomorrow in the coming sessions. Thank you very much.